In this video, we're going to look at, 11.3. And we're going to be finding what's called the area of a sector as well as the arc length. So these are two measurements within a circle. Sector, first of all, let's define what is a sector. So I always kind of like to think of it as like a slice of pie. So it's literally a section of the circle. So this shaded region right here is a sector. And it's defined as a region that's bounded by two radii. Radii is just plural for radius of a circle and their intercepted arc. So it's two radii and where they intersect this arc. Okay, so that region is a sector. So what a sector really is, you guys, is it's just a fraction of the total area of the circle. So if we think about that, the area of a circle is pi r squared, right? That would be the entire area. But we don't want the entire area, we just want a fraction of it. Well, we have been measuring angles within circles, and we know that in every circle, all the way around is 360 degrees. We can be given an arc measure or a central angle, and that gives us the portion of the circle. So like this one, it's n degrees, but we're going to take that fraction and multiply by pi r squared, okay? So that's going to give us the area of our sector. We have something really similar actually for arc length, but instead of arc length, so arc length is this distance along this arc. So instead of us talking about area, this is a fraction of the circumference. So instead of all the way around the circle, it's just a portion along that arc. So if it's a fraction of the circumference, we're going to use our circumference formula. And then I'm going to use the same measurement here. It's whatever our angle is over 360 to get us the portion we want. So for this example, it would be 110 over 360 times 2 times pi times 4, okay? I'm going to show you guys how to simplify that further in these other examples. Okay, so let's practice that here. Find the length of arc BC. So they want me to find this length, okay? And I'm actually going to use a capital L for length. Okay, so we're going to find this arc length, okay? So I'm going to call that L. So I want to find, I need the angle. So it could be the central angle or the arc measure. Remember, those are equal, okay? So 80 over 360 times, and because this is length, it's a fraction of the circumference. So it's a fraction of 2 pi r. My radius in this case is 3. Okay, so I'm going to do a little simplifying. 80 and 360 are both divisible by 10, so I can actually reduce that to just 8 over 36 times, and actually I can do that, but I'm not going to do that. I'm going to show you guys maybe a little simpler way. We're going to use our calculator to help us out. And actually, sorry guys, I don't have a TI-30 with me. I'll have your teacher show you this in class. I'm going to show you on my graphing calculator, but I'm going to go ahead and multiply all these numbers together. So I want to leave my answer in terms of pi. So I'm going to do on top 80 times 2 times 3. So 80 times 2 times 3. I get 480 pi on the top. Over 360 times 1 is 360. So I want to reduce this fraction. We can do that like by hand, I guess, or the calculator can help us. So like for example, the one I can see, I can divide both those by 10 because they both end in a 0. So I got 48 pi over 36. Both of those divide by 12, so I can keep going. So you can reduce that just like we do normal fractions, or you can use your calculator. On a graphing calculator, I'm going to divide. I'm not putting pi in the calculator, so I'm going to do 48 divided by 36. It gives me a decimal. I'm going to hit math and then see where it says fraction. Hit enter. So it's saying turn my answer to a fraction. Yes, please. Hit enter again. 4/3. And then I just leave pi on the top there. So my length is 4 pi thirds, and because it's a length, it's a distance unit, so it's going to be the same unit that our radius had. Now on the TI-30s, and let me double check, make sure I don't have one. Nope, shoot, sorry you guys, I don't have a TI-30 calculator to show you. This one on a TI-30, I'm going to actually draw this up here. Calc. So you're going to type in we could even start with that bigger one. So you're going to do 48 divided by 360, then hit equals, and then you're gonna hit second and then PRB, okay? That's the button you're gonna hit and then hit equals again. And then if it's a mixed number, you're gonna hit second ABC. And so those are the commands on the TI-30. Have your teacher show you that, and that will always give you a fraction in lowest terms. So we want it in terms of pi, but we want our fraction totally reduced, okay? Okay, this time we are finding the area of a sector, so we're gonna use the area formula. So they want this region right here, okay? So my angle out of 360 is 95. Okay, times, because we're doing area, I'm going to do the area formula. So pi times our radius is 10 squared. Same thing, I'm going to treat that as over 1. I'm going to do the exponent first, though. So I've got 95 pi times 100 over 360. I can do 95 times 100 and get 9,500 pi over 360. Again, we want to reduce that. I'm going to use my calculator to help me with that. So 9,500 divided by 360. Notice I did not put pi in here. Okay. And then I'm going to do math, fraction, hit equals. We get 475 over 18. That is in lowest terms. So 475 pi over 18, that is an area. So because it's an area, it's going to have square units. So our unit was feet squared. Okay. What is the difference between arc length and arc measure? So this is the first time we've talked about arc length. Arc length is a distance. So arc length is a distance. Arc measure is an angle. So that is the difference. So this one's going to be in degrees. Right? This one is another distance unit like inches, feet, miles, etc. Okay, so that's the difference. So distance versus an angle. Okay, arc measure is an angle, arc length is a distance. Okay, now it says in your own words, describe where we get the formulas from. So they come from formulas we already know. So area of a circle equals pi r squared. And circumference is 2 pi r. So we get our formulas for sector area and arc length from these two that are already based on a circle. Now, the fraction n over 360 gives us the desired portion of the whole. So instead of the whole circle, right? So these would give us the whole circle, that adding that piece and multiplying by that gives us the portion that we want. All right. Oh, and I think that's it for examples, you guys. You are going to do the Math Lib as practice. Thanks for watching.